The AI trade has been, well, the undisputed power source fueling this bull market for years now.
Absolutely.
We've all watched valuations just soar based on this promise of, this belief that the tech is advancing, effortlessly and exponentially.
Mm-hmm.
But what happens when that digital boom runs headfirst into, I guess, the physical constraints of reality?
That's the question, isn't it?
Okay, let's unpack this.
Yeah.
Today, we are undertaking a really critical deep dive. We're looking into the sources you shared with us, and they center on some recent, really striking insights from one of the most important voices in the whole sector, Microsoft's CEO Satya Nadella.
A voice you have to listen to.
Exactly. And our mission here isn't just to talk about chips or algorithms. We really need to analyze why this massive AI build-out, the trillions in infrastructure spending everyone's tracking, is hitting a severe and pretty unexpected roadblock.
Yeah.
And what that capacity crunch means for investors like you who are, banking on this trajectory.
Right. And this deep dive is so necessary because the market narrative has been, I think, very skewed towards the abstract, the software, the algorithms.
Right, stuff you can't touch.
Exactly. But as we're seeing in these sources, the central constraint is profoundly physical. It's not a code problem. It's not a scarcity of silicon. It's a logistics and a power problem. We are seeing definite signs of fatigue, and those high valuations that are tied to endless growth, they're now being questioned by the very people building the infrastructure.
And when Nadella speaks, the entire sector takes notes. Microsoft isn't just watching from the sidelines. I mean, they're one of the primary architects of this whole thing.
No, absolutely.
They're forging these massive alliances with everyone from NVIDIA for GPUs to specialized providers like CoreWeave for compute capacity.
Right.
So their involvement means Nadella has this unique, really hands-on view of where the system is actually breaking down.
He's on the front lines. And to really appreciate the scale of this bottleneck, we have to start at the source of the demand. We're talking about large language models, LLMs. Okay. These are the foundation of modern generative AI, and they are notoriously power hungry. And it's because of the sheer scale of the data they consume.
So they're the brains of the AI world, but with just an enormous energy appetite.
Precisely. LLMs are built and trained on these massive data sets that use, as the sources point out, literally trillions of words.
Trillion.
Yeah, which are broken down into what the industry calls tokens. Now, a token is basically the smallest meaningful unit of data these models process. And every single operation, whether it's the initial training or the subsequent inference...
Which is just using them all to get an answer.
Exactly. Just using it to generate a response. It requires intense, sustained computation.
So every time you ask an AI model a question, you are, in effect, plugging into a colossal energy drain.
That's a really good way to visualize it. And that all necessitates data centers with a significant and, frankly, an escalating appetite for electricity. Now, there is this sort of theoretical hope that as LLMs get more sophisticated, they'll also get more efficient. That better algorithms will require less energy per token.
The idea that technology will somehow solve its own resource problem before it overwhelms the entire grid.
That's the optimistic take. But the reality check from these sources is, I think, really critical. As one expert put it, it's hard to say what inning of the AI game we are in.
Right.
And it's really difficult to know when that major efficiency leap will actually happen. Meanwhile, the demand for power right now is just staggering, and it's growing faster than the infrastructure can be built.
And the data projections on this scale of consumption are what really, well, they stop you in your tracks. We dug into a report from the MIT Technology Review, and it cited projections from the Lawrence Berkeley National Laboratory. The numbers are just immense.
They lay out a very blunt truth. The current footprint of AI in the U.S. is probably the smallest it's ever going to be.
We're at the starting line.
We're just at the beginning of this build-out phase.
And the future projections are, they're truly alarming. The sources suggest that if the current AI trajectory continues, the sector could end up consuming the equivalent energy of, 22% of all U.S. households.
22%. Just let that sink in.
Imagine powering almost a quarter of every single home in the country, just for AI computation.
It's an almost unimaginable amount of new dedicated electrical supply that needs to be generated and, delivered.
Yeah.
And if you narrow the focus just to the data center sector,
okay,
the projection is even more intense. AI could consume half of all electricity currently being used by all data centers combined.
Half.
Half. So this isn't just a marginal increase, it's a complete transformation of energy demand in the commercial sector.
Wow. Half. That magnitude of consumption. It tells you this isn't just about finding a little extra space on the power line. This requires entirely new power plants, new transmission infrastructure.
Massive utility investment.
The whole system.
Exactly. This level of physical consumption is the fundamental constraint. And no amount of brilliant software can bypass it. It requires vast capital and long-term planning, and it directly challenges the speed we've all come to expect from these digital revolutions.
So that sets the stage for the massive long-term energy problem. But let's shift now to the immediate, tangible bottleneck that's already slowing down the biggest players. Here's where it gets really interesting. This is where Satya Nadella's recent interview on the BG2 podcast gives us the most potent insight for our investors.
Yeah, Nadella really cuts right through the conventional wisdom here. For the longest time, the narrative was that if you could get the chips, the GPUs from NVIDIA, you won the race.
Right? The constraint was all about silicon supply.
And that narrative is what drove NVIDIA's stock price to, well, astronomical heights.
Well, of course.
But Nadella gives a very specific diagnosis of the current constraint. He explicitly says the biggest issue they're facing is not a compute glut.
Meaning they haven't ordered too many chips?
Right. But it's the sheer difficulty of securing power and the ability to get infrastructure builds done fast enough close to power.
Wait, okay, so if Microsoft and the other big hyperscalers, Google, Amazon, all of them, if they're spending tens of billions on this stuff, why are they surprised by this bottleneck? Didn't they secure the land and the power agreements already?
And that is the critical point that Nadella's quote just clarifies beautifully. He provides a stunning, direct detail. He reports having a bunch of chips just sitting in inventory. Sitting in inventory that he can't plug in. It is not a chip supply issue anymore. It's a physical readiness issue.
So they have the million-dollar tools, but they literally have nowhere to build the workshop.
Exactly. He specifically said, it's not a supply issue of chips. It's actually the fact that I don't have warm shells to plug into.
Warm shell.
Yeah, warm shell. It's industry jargon for a data center building that's been constructed. It's secure, and most importantly, it's connected to the massive electrical substations required to power these AI clusters. Getting that physical shell connected to reliable high-capacity power is the new time-intensive friction point.
That is the ultimate physical reality check on a digital boom. It just highlights the difference between making a chip, which can be done relatively quickly in a clean room, versus building a utility-scale building and securing the grid infrastructure, which involves years of regulatory approval, specialized construction.
And utility lead times. I mean, the lead time for getting a new high-voltage line operational or a new substation build can stretch into years.
Years.
This logistical lag means that even though these hyperscalers are spending these vast sums, tens of billions a year to build out, they are already running into capacity roadblocks. The physical world is throttling the pace of the digital world.
This capacity issue must just create a tremendous drag on their efficiency and ultimately on their ability to generate revenue from those massive investments.
Well, of course.
If your chips are sitting in a warehouse, they're not mining data or servicing customers.
Precisely. And this moves us directly into the financial implications. The sheer scale of capital needed to fix this bottleneck is, well, it's astronomical. We saw that JP Morgan Chase estimate. It suggests a staggering $5 trillion will be spent on AI infrastructure over the next 5 years.
$5 trillion.
Just to address these physical needs, this power demand and the necessary data center shells.
That's an amount that, I mean, in historical terms, that rivals the annual GDP of major developed nations. This isn't pocket change. This is a replumbing of global infrastructure.
And that $5 trillion figure really frames the risk profile for investors. This friction, this combination of required spending and unavoidable time delays, it doesn't mean the AI trade is over, but it dramatically changes the risk equation for those high valuations.
This sounds uncomfortably familiar. This whole situation mirrors what we saw during the internet boom, specifically the fiber optic overbuilding of the late 90s and early 2000s.
That historical analogy is absolutely vital for investors right now. Companies like Global Crossing spent billions laying fiber optic cables across the ocean floor. The capacity was built, but the demand didn't materialize fast enough, or the technology got a little more efficient, and it led to what was called the telecom bust.
So the problem wasn't that the technology was bad, but that the speed of the infrastructure build-out just far outpaced the speed of profitable use.
Exactly, leading to massive write-offs and bankruptcies.
Wow.
We are seeing a parallel risk here. If the returns on these $5 trillion investments are delayed because of power constraints, or what if a major efficiency breakthrough arrives sooner than we think?
It could make some of this expensive new build obsolete.
Precisely. You risk a similar reset of stock prices based on overcapacity and delayed returns.
That shifts the critical questions for investors entirely. It's no longer just about who has the best algorithm.
No.
It's about when will the returns on these enormous multi-year infrastructure projects actually be realized? And what happens if the build-out driven by, competitive panic proves to be excessive?
If AI doesn't become as completely ubiquitous as we all currently imagine, that's the true challenge for investors. Moving past the boundless enthusiasm for the technology and factoring in the physical, the bureaucratic, the utility constraints, it's easy to focus on the upside of AI transforming every industry. It's much harder to factor in the lack of available land near a major substation and the 3-year lead time on custom electrical gear.
Which brings us right back to the warning that was embedded in the source material.
Yeah.
Investors must review the stocks they own and take a truly objective, critical look to justify any valuations that seem exorbitant.
Mm-hmm.
As the source noted, even the best stocks in the world have a price. We even saw Microsoft's own stock activity reflecting this reality check, showing a recent dip at the time of the sources.
The market has a way of humbling even the largest players when physical reality catches up to digital enthusiasm. The lesson here is that capacity constraints are a fundamental variable.
Right.
The speed of the AI revolution is now dictated by megawatts, utility permits, and construction schedules, not just by lines of code.
So what does this all mean?
It means the race to develop advanced intelligence is now fundamentally constrained by the physical reality of energy and infrastructure. It's that simple. This challenge demands massive capital, that $5 trillion, and a lot of time to resolve.
Okay.
So investors really need to shift their focus from anticipating the next chip iteration to understanding the friction caused by the utility grid and the construction pipeline. The slowest player in this race isn't the software engineer, it's the power company.
We really appreciate you sharing these sources because they so clearly illustrate the value of looking beyond the headline hype of AI chips and algorithms
Yeah.
and focusing on the hidden capacity constraints that govern the entire sector's growth.
The unsexy physical stuff is running the show now.
Indeed. We'll leave you with this final thought to mull over. Given the projected consumption levels up to 22% of U.S. household energy, if the core issue shifts from a temporary power shortage to a sustained perpetual need for massive amounts of new, clean energy capacity, which adjacent industries outside of the direct AI hyperscalers and chip makers stand to gain the most from this fundamental resource race. Think about the implications for utility providers, sustainable energy companies, and transmission infrastructure developers who are suddenly facing guaranteed generational demand.